Hello everyone, welcome to this episode of the visual novel series where we're going to work on character colors. So last episode we made it where we could set the images on the different layers of the characters to change their expressions, whether that be their body, their face, or whatever you have on any given layer of a character. You can change it and you can get all the sprites from their art assets directory. Now, how about let's go ahead and start making it where we can change the color of these individual layers or the character as a whole. Useful situation for this is if you want maybe your character to flash on the screen. Color flashing. And you could also do like darkening a character or highlighting a character to show who's speaking at any given time. So we're going to be working on stuff like that. So let's go ahead and open up our character sprite class and get started. So color is going to be applied to many different characters. Obviously not text characters, but many of them. And we worked with expressions and setting and getting sprites specifically in the character sprite class last time because that was very specific to sprite characters. Color, not so much. Color can apply to whatever type of character we're working with. And since we had movement available to almost every single type, we decided to just go ahead and place that inside of our character class. You could, if you wanted to, I guess, make a class that's like character graphics or graphic character and then have it inherit from character and then have character sprite and character live 2D, 3D model inherit from graphic character. And then you can isolate code like that. It's a bit too much of a hassle for something as small as what I'm working on here, which is just the only character that's going to be, the only character class that's going to be limited is the text character. So I could just put in constraints with some of these to prevent the text character from actually trying to run some of these non-applicable functions. If you don't want to do that, by all means make yourself a different class, but it doesn't bother me any, and I'm not worried about that being an issue. So I'm going to be putting this in to our character class. Let me see if I can remove that breakpoint. Can I get rid of you? What are you doing there? Get out of here. You don't want to move, do you? Why are you in there? Get out of here. Ugh. Get out of here. What are you doing? It does not even want to move. What the heck? There we go. That was weird. Okay, moving on from that. So similar to how we did the root check on move position, well, we'll just kind of do the same thing for color. So let's go ahead and come down here and make ourselves a new function that we can override for the different character classes. So we'll make a public virtual void called setColor, where we'll set the color of this character, and we'll simply pass in a color variable. And what we're going to do is change the color that's assigned to this character. So this is not the color that would be on the sprite, but this is a color variable that would be referenced by the other classes to then set and define and change their colors. So just a little variable. So let's come up to our variables in the top and make a little spot for our color. So we'll just set public color to equal color.white. Now I don't want this color being set directly from the outside, so we'll make a public getter, but then we're going to make a protected setter. That way any inheriting character can change this color. And now let's go all the way back down to our set color script, and the only thing we're going to do is say that this dot color equals the color that we've applied. So now let's go ahead and override this for the character sprite class, and we can change the color of all the renderers that we're using. So down at the bottom, let's make a public override, and we're going to be overriding the set color. We'll call base set color, so that way we assign the color for this character. And then what we're going to do is we're going to go through each layer on this character and apply the color there. So for each character sprite layer in layers, we're going to make sure that we're not first transitioning to any color, and then we need to set a color on this. So what we do in here is we need to set the color on the layer, but we don't have that logic, so let's go ahead and create it. In our character layer, let's now make a function that can set the color for this layer. This is going to be pretty simple. We'll make this a public void called setColor, taking in a color. And let's go ahead and make the renderer.color equal the color that we're assigning. And then for each old renderer inside of our renderers, we want to make sure that their colors are updated too. So our old renderers are canvas groups, and we'll call it old CG. In old renderers, we want to do something. We want to say old CG.getComponent image.color equals the color that we're assigning. And then inside of the character sprite, we simply call that on layer.setColor to the color that we're trying to assign. So in test characters, let's go ahead and say, let's yield, oh no, we're already waiting for a second, so we'll say raylene.setColor, if I can spell her name right, that is, raylene.setColor to, what do you think about red? Sexy red, alright. If we run that logic in Unity, we wait a second, and then we set her color to red on every single layer. Or we could come through and say raylene.layers, and then access her second layer, and call setColor on that to set color red. And then what happens is only her face will change the color red. So you can see how that'll work. But that's no fun. What we want to do is we want to gradually change the color of the character and have it fade in. The first thing we want to do is, of course, we want to keep track of the process. So we want to come and add a coroutine for this particular event, which will be a protected coroutine CO, and we'll call this changing color. And then let's go ahead and see, add a public accessor that'll tell us whether we're changing the color or not. Is changing color. And that would be if our coroutine is not null. Now, from our character, let's go ahead and make it where we can call this. So we'll have a public variable or function that's returning a coroutine type, and we're going to call this transition color, taking in the color that we want to move to, as well as the speed of the transition, which will default to 1. So first thing we're going to do, just like with setting color, is we'll say the color variable for this character is going to equal the color that we've just assigned. And now, if is changing color, we want to make sure that we stop it. So we'll access our character manager, which is running all of the coroutines for this, but I've got it called manager here. So that threw me off because that, I'm gonna just rename that to character manager because I've got it called that in the other script. So yeah, that threw me off for a second. So character manager dot stop coroutine, we want to stop co dot changing color if it's running. And now we need to start the process of changing this color for this character. So we'll say co changing color equals our character manager, oh geez, our character manager dot start coroutine, and we need to define a coroutine to start. So this is what we're going to be overriding for the different character types. So public virtual IEnumerator, and this will be changing color. We're going to take in the color that we want to change to, as well as the speed that we're going to run this process at. So when we start the coroutine, we'll reference changing color, passing in our color and our speed, and then simply return co changing color. And now for changing color, we can't do this on a base character, so we'll say debug.log, and this would apply to the text character if we were trying to call it on them. So set color. Okay, so we can call this from our character class, which means we now need to override it for our sprite character, But before we do that, we need to actually set the functionality for our sprite layers because they're going to be handling the colors. So we'll first make the coroutine to transition the color, or the function to start that process. So we'll have a public coroutine return type for transition color, just like for the character. And we'll take in those same values too. We'll have the color, and then we'll have the float for the speed. Inside of here, since we're running this coroutine on a layer, once more we need to keep track of the progress. So let's come up top and make ourselves a new coroutine, private coroutine, CO, and this one we're going to be calling changing color, just like we did for the last one. And then public bool is changing color. There we go. Let's go back down. And so if is changing color, then we're going to go ahead and say our character manager dot stop coroutine, and the coroutine we want to stop is that changing color coroutine. That way we can start it. So CO changing color is going to equal the start of a new coroutine. Let's go ahead and define a private IEnumerator that'll handle this for us. So when we transition the color, our coroutine, let's go ahead and start that on our manager. Start coroutine, changing color, and pass in the color and the speed. And then return CO changing color. So then that begs the question, what are we doing inside of here? Obviously, we're going to be changing the color on every single layer, on the image of every single layer. Just like we did for set color, we accessed the main renderer and then all of the old renders. So we're going to be doing the same thing, but using a method to gradually change it, which in this case will be the built-in function for color called lerp. So the way that color lerp works is it'll smoothly change a color from one value to another over time. And you specify a starting color, an ending color, and then a value that represents the percentage of the transition completed. So for that, we're not going to be able to reference our current color like we did for the alpha of the expressions. Instead, what we want is to cache our old color. So we'll say color old color, which will just equal the current color of the renderer. Once we've got that, we need to cache a list of all of our old images. Since they're stored as canvas groups, we don't want to try to get the image component every time. So to give ourselves a little performance relief here, let's make old images and set that equal to a new list of images. And then let's just go through and get all the images for our old renderers. So for each, and we'll say var old CG in old renderers, then old images equals old CG.get component image. And so, or rather not equals, but dot add to add it to the array or the list. Getting all my words mixed up. So that'll cache all of our old images, and then we can change their colors in another separate loop here. But as I said, the color.lerp keeps track of the color change and sets it by a percentage, so we're going to want to keep track of what our current percent is. We'll represent this by a float called color percent, and just set that equal to 0 right now. And then let's say while color percent is less than 1, then we know that we still need some transitioning here. So let's go ahead and add to our percent. Now we'll work with the same default transition speed that we defined for the images. We'll use the same one for color because 3 is still a good value. So we'll say old color percent, so we'll say color percent plus equals our default transition speed multiplied by our speed multiplier multiplied by time.delta time. And then we can say renderer.color equals color.lerp to move us to the value we're supposed to be at, specify the old color that we started with, then our target color, which is going to be color, and then by the time, which is our color %. And then we just need to do the same thing for our old renderers. So for each image, then old image in old images, let's go ahead and say old image dot color. And they should all be using the same color. There shouldn't be any reason why we should have to run these independently of each other. If we're setting the color on one renderer of this layer, then we can assume that all of the old renderers should be the same color because it's all the same layer. Really, what we can do here is just simply reference the renderer.color, so we're not pulling math equations more than we have to. And they're all supposed to be the same thing anyway, so that'll work there. And then we'll just go ahead and yield return null. And once we finish all that, then we'll say co changing color equals null. So this should allow us to transition colors on our layers. Now let's go to our character sprite and make it where we can actually call that on each layer. We've got the set color, so right below here, let's go ahead and make ourselves that function that's going to override the changing color coroutine that we made earlier. So we look back at character, we call transition color, and it starts this changing color coroutine on the character class, which is a virtual IEnumerator, so we can override that and give specific behavior to whatever character class we're working on. In this case, character sprite. So we'll say public override. What we want to override is changing color, and we don't need the base function because that's doing nothing. But what we do want to do is we want to go ahead and start the transition of the color on each of the layers for this character. So we'll say for each character sprite layer in layers, we want to access the information. We want to access the layer and change the color on it. So layer.transition color to our color by the speed we're providing. And we need to wait for those coroutines to start, and that way our is transitioning boolean will be true, and we can figure out how long we need to wait. So let's just go ahead and yield return null. That way we wait for those to start, and then let's check if any of them are still transitioning. So while layers.any, again using system.link, we're going to check every layer in here represented as L. So if L.is changing color. So if any of our layers are still changing color, then let's go ahead and yield return null and just wait for it to complete. Once we're done, we'll go ahead and say co changing color equals null. Easy as that. So if all goes well, we should be able to call transition color, which will then call changing color on our sprite character, which will then look towards each layer and call them to transition their colors, and wait for every single one of those layers to complete, and then end itself. So let's test that out in character testing. Right here, I'm going to go ahead and say that Raylene, let's go ahead and get rid of the layers. So Raylene.transition color, we're going to transition her to red, and we're going to yield until that is completed, and we're just going to go through a couple different colors. So we're going to go through blue, because I love blue, then we're going to go to yellow, and then we're going to take her right back to white. So let's run that in Unity. And okay, yeah, we can see that she went through all of her colors. That was a little fast though. Let's just change the speed on this one to be, let's say, 0.3. How about that? And then we get a much slower fade on that first one, and we can really see it all working together. Okay, so I'm going to end off this video here because that's all we really need to know about setting colors on characters. So in the next video, we're going to look at lightening or highlighting and darkening characters to show who's visible and actively speaking at any given point in the novel.